Hi everybody, I hope you're doing well. I miss you guys. Teaching from my kitchen is definitely not as fun as teaching in the actual classroom. I hope you're staying busy and keeping from being bored. And I hope you're also finding the radicals unit super fun. It's going to be awesome. This unit actually isn't too bad. The next unit we're going to do is actually probably one of the hardest ones, I think. But we'll worry about that later. So anyway, I hope you're doing great, and talk to you soon. We're going to talk about dividing with radicals and how we rationalize a denominator. So that's going to be something a little bit different, but it's not hard. So a couple things you need to remember. All right, pause the video, fill in the blanks, and then we'll talk. So for the first one, root 2 times root 2 is really like root 2 squared. If you know root 2 times root 2 is root 4, which is 2, then you can just put 2. And therefore, root 5 times root 5 is obviously also just 5. So if you had like root 7 times root 7, that's going to be 7, right? Oops, just 7. Or root 100 times root 100 is 100. So keep that in mind. And then for number 3, you need to know that you can write this problem like root 10 over root 5. You can also write it root 10 over 5. Like you don't have to have that fraction bar separating two radical signs in the problem. And then obviously we can divide that. So that would actually be root 5. And you also need to know that you cannot have a radical in the denominator. And so that's going to be the point of today's lesson. It's called rationalizing a denominator, where we will not have any radical signs in the denominator. Okay, so for root 6 over root 2, we can write this as root 6 over 2, or you can think about it that way. Root 6 over root 2 is going to be root 3. And then a little more complicated is if we have numbers in front of our radical signs. So 2 root 10 over 3 root 2. Notice there's no addition or subtraction here. That's very important. If they're just all being multiplied together, that means we can simplify just this part. And so root 10 over root 2 is root 5. So this would be 2 root 5 over 3. All right, you try this one. So it's going to be 4 root 12 over 2 root 3. So pause the video, try this, come back, check your answers. All right, we know this can simplify to be root 4, which is actually 2, but we'll get to that in a second. And then we can also reduce this part, so that's 2 over 1. And since we can find the square root of 4, which is 2, then we can multiply 2 times 2, which is 4, and that just is our simplified answer. So you try this one, simplify, pause the video, come back, check your answers. All right, I know that this part is going to simplify into root 8x, because 24x divided by 3 is 8, right? And I got the x there. And then I can reduce this to 4 over 1. Or I really could just write it as 4 root 8x. All right, this one's a little bit trickier. It's got some variables in there. So pause the video, see what you can do, come back, check your answers. All right, this one you might consider rewriting it. So I can reduce that in this 2 over 1. Actually, I'll just leave it as 2. This part can also be written as root 8x to the 11th over x squared. And when we divide with exponents, we subtract them. So we also can write this as 2 root 8x to the 9th. And that is our our final answer. Not our final answer, our almost final answer, because we can still simplify this even more, just like we did the other day. Because the 8 can be simplified. So I can have, because 8 is 4 times 2, x to the 9th is x to the 8th times x to the 1st. Remember this part? And therefore, I can take that out, times 2, take that out, x to the 4th. So I have 4x to the 4th and 2x on the inside. That is my final answer. Now, if this part confused you, you might want to go back and rewatch that video. I think it was the day 3 where we simplified, because that's just simplifying. So this is putting like all the radical stuff together. It's going to be awesome. All right, try this one, pause the video, come back, check your answers. So I can reduce this, and I can also reduce this mess. So I'm going to get 3 into 27 is 9, and 8x over x to the 3rd is x to the 5th. And can I simplify anything? Yes, because 9 is a perfect square, so that's a 3. So I'm going to get 12. Oh, and I still have this x to the 5th, which can be x to the 4th times x to the 1st. So I can take x squared root x. So 12x squared root x is my final answer. You could have done that step along with this. I just forgot. So if you got that, good job. Okay, so here we have root 5 over 3, and there's no perfect squares, and Miss Granith already told me I couldn't have a radical sign in my denominator. So my first step, for now anyway, is probably going to be to separate these 5 root 3 over, or sorry, root 5 over root 3, and then I don't care if there's a radical sign in my numerator, like that doesn't matter. But I know I can't have one in my denominator. And the only way to clear a radical sign from the denominator is to multiply it by another radical sign. And I'm going to multiply it by root 3, because root 3 times root 3 is going to give me root 9, which of course is 3. And we know that whatever we do to a fraction on the bottom, we also have to do to the top. So I'm going to get root 15 over 3. Now, I can't divide a radical by a non-radical, so I can't like simplify that into 5 or anything. But that's my answer. There's no square roots in the denominator, so the world is happy and awesome. So rationalizing the denominator removes the radical sign from it, and then we can be happy about that. Okay, so knowing what we just did with the last one, you try this one, root 11 over root 6. Pause the video, come back, check your answers. So if I'm going to do this, I'm going to, for now anyway, I'm going to write it as root 11 over root 6. And I know I can't have a radical sign in my denominator, so I'll multiply it by itself. That's going to give me 6. And then root 11 times root 6 is root 66, which is a famous highway anyway. So root 66 all over 6. All right, you try this one, 4 over root 2. Hopefully you multiplied the top and the bottom by root 2. We're going to get 4 root 2 over 2. And we can also reduce this fraction. So I'm going to get actually 2 root 2 for my final answer. Now, some people ask usually, why can't I simplify all 3 of these? Don't forget, this is one term. There's no addition or subtraction in it. So it's just 4 root 2 over 2. This is one term, this is one term, which means I can just reduce those. I don't need to worry about that radical sign there. This one is 3 root 5 all over root 8. Pause the video, come back, check your answers. So you can actually do this one a couple of different ways. I'm gonna do it like the better way, I guess. Not necessarily the easier, but the better. So root 8 is not simplified. And if I simplify it, I'll have 3 root 5, and then root 8 is 4 times 2. So that's 2 root 2. Now I only have to multiply the top and the bottom by root 2, because I don't care if there's a 2 there, I just care if there's a radical. So I'm going to get 3 root 10, and then root 2 times root 2 is 2, so 2 times 2 is 4. 3 root 10 all over 4. 10 can't be simplified, so I'm happy with that. Now, you could have probably, some of you did this, done root 8. Then you're going to get 3 root 40 over 8. And then you're going to have to simplify root 40. And then you're going to have to simplify this stuff after you simplify root 40. So it's a little more complex if you do it this way. Whereas if you simplify it first, it's going to be a little bit easier in the long run. All right. Copy the problem. Try it. Come back. Check your answers. So I'm going to simplify mine first. 12, root 12 is 4 times 3, and 4 is a perfect square. So I'm going to multiply that by 2. So I'll have 5 root 5 on top, 6 root 3 on the bottom, and then I can multiply by root 3, and that's going to give me, I'll do it down here, 5 root 15 over 6 times 3, which is 18, and that is all I can do. So 5 root 15 all over 18. And of course, you can't get too far without running into some variables, so copy the problem, try your answers, or come back and check your answers. All right, I'm going to multiply the top and the bottom by root y. So 3 root x times root y is really just 3 root xy. And then root y times root y is just y, so 5y on my denominator. There's my answer. You can't cancel these. One's under a radical sign, one isn't, so we don't need to worry about that. And that's all I got. Just a little challenge problem. It's also kind of leading into our next lesson. So pause the video, try it, come back, check your answers. Hopefully you noticed that we've got an addition sign here, so we're going to actually be distributing this. So if you didn't distribute, I would pause this video here and then try it again. If you did distribute, let's see what we did here. 3 root 3 times 2 root 3 is going to give me 6 root 3, 6 root 9, and that's going to be 3. Maybe it'll help you if I do this. 6 root 9, I'll get that in a second. And then 3 root 3 times 5 root 6 is going to be positive 15 root 18. And then I can go here and simplify. So that's a 3. So 3 times 6 is 18. Root 18 can be 9 times 2. So that's a 3. That's going to be 45 root 2, and that's all I can do there. So if you got 18 plus 45 root 2, then you win.